Hello viewers, here is an old Vornado fan. Let's see if the information tag is still with us. Oh, it is. This is model B24C1-1. And it's old, made in America. It's actually in really good condition cosmetically. It could fairly be repainted, but other than that, there's no dents to the surface whatsoever. And it's getting harder to find these units without dents, because they dent fairly easily, because this is hollow, and people don't necessarily take care of them as well as they should. Unfortunately, mechanically, this thing is an absolute landslide. The bearings are probably stiffer than what's usable. I don't know, I've never plugged it in because the wiring is beyond spoiled. I zoom in here and you can see that would just short out. It would go right to ground, so we can't plug it in and give it a test yet, which is kind of unfortunate. So what we're going to do here, I'm going to try to open up the motor, and I believe I have some cloth cord. Oh gee, I didn't even see this. This whole lead is actually bare copper. It's just disintegrating. Yeah, anyways, so this is going to have to be rewired. It looks like it was rewired at some point, because you can see here this cord is not new, but it's newer and it's in perfectly good condition. I have some old cloth cord that we can probably put on here for a permanent restoration fix, but just for now, for the sake of getting it to run, I want to see if we can get it rewired relatively easily, even just with a test wire. Now, I haven't worked on one of these fans in a while, never on this particular model, so I'm just kind of learning as we go along here. We're going to take this screw out, and I believe that's going to reveal some parts of the motor. Okay. So if we really wanted to, I could rewire it right here and at least power it up. I know the bearings need to come out and be cleaned up, but just to see if it at least runs, we're going to go ahead and do the rewire from here. This wire, fortunately, I believe is okay. It's like cloth, but this wire needs to go. So let's see if I can get these things to uncrimp. Had mixed results with doing this. Alright, I don't think they're going to uncrimp. Actually, you know what? It's kind of coming. Go. I'd like to avoid losing as much of this lead as possible. Oh jeez. Injury number 1 on this project. Something with more mechanical advantage, like a large pair of channel locks, perhaps would make this task a little bit easier. Let's see. Okay. Let's see what kind of wire we got over here. I think we're just going to use this wire for now. This won't look the greatest. Actually, it's behind the fan, you can hardly even see it. We're going to use this wire. This will be good enough for the test. And let's see approximately how much we're going to need here. Go with about that much. And of course, this is heavily oxidized and should be restripped for the permanent installation. But again, this is just for the test here. I'm going to just reconnect it as it was. Now I believe if you plug this directly into the wall, this would just give you high, but I'm not 100% certain on that, so I don't want to do that. I want to investigate how the wiring scheme is in here first. So here's our speed coil, and let's see what we have here. So look, I don't know how many speeds this is supposed to have. I can't tell from just turning that. It doesn't have any sort of indication on there. But either way, it looks like this is going to be where the fans wires came through. Let's see here. Now that's kind of interesting. This is obviously this is old enough to be non-polarized. How? Alright, well whatever. I'm just going to wire it up the same way it was and hope that it's wired up correctly. I'm going to have to cut this. Alright, so the motor leads. What is this? Some kind of a washer or something, or what was a washer maybe. The motor leads go to here. I don't really understand what's going on here yet. I have to spend some more time investigating that. But I'm going to go ahead and cut this off. And pull this out, because unfortunately it's just of no use anymore. And quite frankly, I think I'm going to cut it up here as well, just so we can get it out, because it's not going to come easy. Okay, so that's that. This wire has surpassed its useful lifespan, so that's going to go in the scrap pile. And we'll feed this through. And we know one side's going to connect right here, so we'll go ahead and make that connection now. And then I'm going to have to strip those other wires again, because it looks like they've disintegrated enough to have broken off with the other piece. Well, looking at the wires, it's probably a oh dear, that switch is coming apart. Looking at the switch here with the wires coming out of it, I would guess it's a 2-speed switch. So this probably gives us, this must send the wire, excuse me, it's getting late. This must just create the low speed, and then high is probably just straight to the line voltage. At least that's my speculation. Again, I really haven't looked into this as closely as I need to understand it, but that's my guess for now. And ideally all this wiring should probably be replaced. I think the insulation in this is deteriorated beyond what's really safe to use. This is just one strand of copper. I don't quite understand that, but so this whole thing should probably have some kind of like a string tubing or something put on there, because this is not good. Unless this is varnished, which I guess it could be. I don't know. I can't tell if it's varnish on there or just oxidation. Well, let's connect it up and see if we can get it to run. It's not going to run well because of the bearing situation, but if I can at least verify that it has potential to run, then I will go through the bearings and get that taken care of as well. Okay, now the connections are made and we're ready to attempt to turn it on. You can see I've never even tried to plug this in since I bought it. It's still wrapped up from actually, I don't even know where I bought this. It's been so long. Let's see what we can do about this here. I'm kind of nervous to put the metal on this. You know what? I'm gonna really concerned about anything shorting out in here. I think it can sit like that relatively safely for the test. Yeah, we'll just do that. I'm not thrilled about that, but whatever. Get the kilowatt meter out here. Oh, good if I get the kilowatt meters upstairs. Oh, forget it. Either it's going to work or it's not going to work or it's going to blow up. It's got to do one of those things. Alright, I hear it. So that, whatever that speed is works. That's off. Alright, it is working. So I'm going to grab the kilowatt meter here and pick back up on the video when I find it. Okay, I got the kilowatt meter connected here. We're testing at 119 volts. That was pulling 129 watts. It's pulling 62 watts. And this should be nothing. Okay, so it does want to work. As much of a disaster as the wiring was, and the bearings still are, it shows enough promise that it's worth proceeding. So we're going to go ahead and disassemble this and see if I can free up the bearings.